Alright, we are live, I think. Hopefully we're live. OBS has been acting up recently, so I don't even know anymore what's happening, but yeah. This is day 41 of studying compilers every day until I land a compiler role. Let me move my mic up. Okay. Yeah. So this is day 41 of studying compilers every day until I land a compiler role. We actually don't have LeetCode today yet, because it's an earlier hour again. Because my friend scheduled mandatory movie watching time at my normal stream time. So, yeah. Once again, this is all a very ambitious list of things I want to get done. There's a very low likelihood that it actually does get completed, or at least like in its entirety. So for the most part, I think we're going to be focusing just on this solely. So last time we added branch and control flow to the parser and the AST, but now we just need to propagate that down all the way down to, whatchamacallit. We need to propagate that all the way down to just the optimizer IR. Hey MD, good to see you. Yeah, so yeah, I guess we'll be adding it to HIR. Let's just pull up Wes term again. So I made a couple of changes overnight. It's not too much, but it's mostly just throwing some additional stuff into the HIR just to save a little bit of time for today's stream. I guess I can show that real quick. It's nothing too spectacular. Yeah, so we have 3 new instructions here. The first one, instruction, yeah. So the first one is a label. It's pretty self-explanatory. It's just like, let's add a temp file. So if we have like int main, if we have like, it's like if we have, say like, this will make more sense for like while loops, but we're basically replacing all of the fancy control flow statements with just boilerplate label and jump sort of equivalents, I guess. So we can have a label like if label, and then we have like a so that's the label class. And then the idea is then we can target those labels with branch statements. So we have branch there, so we can have like branch if label as an example. And then we also have branch cond, which is a conditional branch. So the idea here is like int I equals, let's say 5 less than 6, and then I guess this should be like bool, but then we can do like branch cond or something. I don't know how the syntax will look like when I print it, but so we have this, and then we can pass in I, and then like if label, if it's true, and then we have like done label down here as an example. Are you into AI or ML? Not really. I feel like I should be more into it, but I just haven't really had that much of a chance to, I guess. So yeah, so it goes. I also just been too busy writing the compiler wave, so yeah. So we have this sort of boilerplate generated. So what we need to do is I've added to-dos for all of the different visitors that we need to, or I guess all of the visitors we need to complete based off of these. So we have one in AST to HR, we have one in HR to MIR, and then we have MIR, or we have HR to string. Let me turn off the AST again. Yeah. So I guess we could start with AST to HR. This should be pretty reasonable. It's just one to do, so should be pretty quick in theory. Okay. So if has a condition, a true branch, and a false branch. And then Yeah, so we can, I think we could recursively call for the true branch and the false branch, but we also need a way to generate unique labels is the other complication that we have, I think. Not really sure how I would go about that yet, but I'll figure it out. So we want cond. Let's go and get cond. Should I be, I need to, how is this generated? This should be a use scope, I think. Right? Yeah, this should be a use scope. .get. That's what I'm missing. So what will an if statement look like, I guess, with jumps? Let me check something real quick. I have a reference somewhere. I think it's here. Yeah, okay. So we have like if true, or like if cond, then something else something as an example. And then we also would have to process without else separately. So this one would become, also I'm using Notepad because I'm too lazy to pull up the Neovima again. How do you want to clean this up? So we want a conditional branch. So I guess cond. So we would want it to pass in cond. Then we want I guess like true label and then false label. And then we want, so we also want another label. So we want a true label, we want a false label, and then we want a done label. Or as I continue. As an example, I'm using Vim binds in Notepad. This is breaking my brain. Okay, so then in the true label we have the body, and then we have a straight jump to the continue. In the false label we have the body. Yeah, this should be pretty straightforward. This also naturally lends itself well to basic block generation, I think. So yeah, it should be quite interesting. And then this also means we have to worry about like generating basic blocks as well, but that should be fine. I'm not that concerned about that yet. So this is the idea for this case, and then the other case we need to worry about is if there's no else. So it's just this. And in that case, I think just yeah, then we just, so we want cond, we just have a true label and then continue. And then we can skip the false label completely and this branch. Yeah, so it would look like this pretty much. So yeah, I guess I get to pencil it in now, which is fun. Let's get it in. I am trying to get if statements to work, but the way I have written it is very spaghetti codey, so it's a little bit of a mess. But that's always where the fun is. Okay, so we want to generate instruction branch con regardless. We also need two labels? I guess it might be useful to separate it out just if the else block exists. So I think I encoded it so that if the false branch is a null pointer, there's no else. Most of my streams are about to get so short this quarter time-wise. Yeah. I mean, you're the one that's employed out of the two of us right now, so I mean, you're kind of winning out here, low-key. So I wanna get F branch. Alright, this should just the unique pointer should be a null pointer. Yeah, so this should be the if else. Nah, I mean, if you've seen what business people are like, I think we can figure out which of the two matters more. Okay. So what is the difference between these two roughly? I can just throw this into a diff even. That might be funny. Yeah, I haven't done the getting started lab yet. It didn't seem that hard. Low-key, I don't see a reason to do any of it on more, so I might just do it all locally and call it a day. Okay, yeah, this seems reasonable enough actually. Yeah, okay. Yeah, this diff makes it really easy to figure out how to interweave. Yeah, so yeah, it's like you're recommended to do it on more, but if you have like a Unix-based system, you can do it locally. Apparently, like, Brandon was like fine with doing it on WSL as well for whatever reason, so yeah, it seems flexible enough, and like realistically I don't think I'm gonna now that I think about it, I don't want to have to like set it up twice, so I might do it off more, but then I have to like set up NeoVim, which is like more annoying on more, so yeah, I might just set it up on like my laptop and call it a day, and just pray that I don't have to do PC work. Or maybe I just buy a KVM switch, I don't know. Okay, so we want to make a branch statement. I guess we should make the 3 labels first. That will clean up a lot of the process. Okay, I also think we need a label maker thing somewhere. Okay. So let's. Jesus, this is already such a mess. Can just make a label count mapping. This is gonna be really funny. How do we do this? Let's make a putter to we want a unique putter to label. And this will be called, it should be HR label. Label or make label. Because that's a good question actually. Yeah, I don't know what old me was thinking. Yeah, I really should just pass old table in by like by reference, yeah. I guess I was like scared of like doing some crazy mutability shit, but oh well. Okay, so make label. Oh, this is hidden by the camera. There we go. So we want to give it the name, I guess. And this is important because we want to avoid name collisions. Or I could just I could be stupid and just give labels numbers instead. How recenter is easy. How do I want to make labels? Yeah, ZZ is goated. I am so glad I accidentally discovered it once. You know what? We don't need to give these names. No, we need to give these names. Yeah, let's give it a name. The only annoyance here is that I need to worry about label collisions, which is why I ended up just avoiding giving things names further down in the actual optimizer. But for now I think I need to give things names, which really sucks, but whatever. Is this the correct file? Resolve use scope. Oh yeah, here it is. So this is in the visitor. Okay. How do I want to do this? I guess we check the symbol table. I had an interface for the symbol table. Has symbol. Okay. Maybe we keep a count as well? Yeah, we should keep a map with the number of uses. And then... yeah, this gets really ugly really quickly though. Yeah, I think this is the safest way to go about it at least. So we're gonna have to try. Oh, this needs. Does this not have symbol table? Oh, new table. What is the best way to resolve this? How do we give it a unique name? I'll just start with... This sucks. This really sucks. I hate this. How does LLVM do this? I know it just straight up has names reserved for this, but how does it avoid collisions with variables? This sucks. This fucking sucks. Holy shit. I should check old table actually. Because the new table will necessarily end up having it. Oh wait, no, actually it won't be a problem, I think. It won't be a problem unless a function shares a name, because we're already getting rid of scopes anyway. So we're already appending a 1 after every variable. So then we just have to compare against the functions, which is really annoying. Let me look up. C has a function name allowed characters. Because I think there was a thing where you can't start it with like a underscore or something. Or like a... There was like something that you couldn't start it with. C function legal names. Okay, so that... Certain... okay. Ah, here we are. Okay, perfect. No double underscore. Okay. No double underscore. Let me just make sure this exists. Yeah, okay, perfect. Okay, so that allows us to clean up a little bit of stuff. So we can just start it with double underscore. So then there's 0 chance of a naming collision, actually. Yeah, we can even skip this make label shit, honestly. Or maybe we just keep it and we just assume that we don't have a collision. Let's just get rid of it for now. Or I guess we can just... Let's do this. Let's just do that. And then if it comes up, we will do something about it. It absolutely will come up. Okay. Auto... Should make 3 labels, I think. Okay, I lied. We do need this. We can just keep a count inside somewhere. What's good, Frothy? Good to see you. Where did I put this? Let's throw this in here. How are you doing? I am like banging my head against the table, trying to figure out how to avoid name collisions. And I looked it up because I remembered there was a thing, and it turns out you're not supposed to start variables in C with like a double underscore, which means I can freely use that at least. Yeah, so that's a good time. Oh, in C++, you just straight up can't use a double underscore. That's crazy. Okay. So yeah, I'm just gonna keep a map, I guess. Map from... From string. We're not gonna do int here because I guess the value in the symbol map that we're comparing to will always be changing, at least, because we want, for each if statement, we want to generate like different internal labels, so we can't really compare to like a single one for a count. Yeah, so we have a string, and then we have like, let's have a big number. So we have label counts. This is the wrong file. God damn it. Whoops. So there we go. We need make label here. How do I make a label? Return. So we want make unique, everyone's favorite. So what does label take? I think this just takes an atom, right? So so we want to create unscoped identifier. So we want a number. So we have count equals label counts at name, and then we want to postfix increment that. So then we can just omit the prefix thunder. So we want. Have you seen the new H1B visa fuse? I haven't looked into it. Yeah, I'm trying to avoid commentating on the current state of the country for various different reasons, but some things are a little hard to look at and look away from. Okay, so we get the double underscore, we add name, and then we add count, I guess. So we want toString. Oh, what's wrong here? Oh, right, we can't say name. Label, oh, whoops, str. So this we just give get that, and we need so we need the identifier that actually is the label. So we want create unscoped identifier. And this takes in label str, I think. Yeah. Oh, I need to fix that still. But yeah, finally, then we can just move, I think. We just move identifier in here. And then return res. Right, does that work? I hope that works. Okay, so anyways, now that we have a label maker, you know, like the little label maker machines, like one of these. We've basically made one of these now, which is pretty funny. Yeah, now I can do that. Yeah. So we want make label, and then we want to give it if label, or I guess like, what do you want to name these? If true, I guess. Yeah, if t, I guess. And then we can do the same with f label. We should maybe ternary operator this. So we want a quick bool. Has else, because if it doesn't have an else, we need to like change the control flow a little bit. So, so has else will be I get f branch equals null putter, or not equals null putter. So if it's not a null pointer, we have an else. So then, so the false label will be has else. So if it has an else, then we make that. Otherwise, it's a null putter. And then, just to make sure this is correct, this is a unique pointer of label. Okay, perfect. And then we need a continue label regardless. If cont. So and that's what keeps execution going. Okay. Okay, so then if we go back to the diff checker, so we've made the labels, so now we need to actually create this branch condition thing. Become a compiler? Yeah, I'm compiling compiler knowledge to make a compiler. And hopefully I can compile a compiler with this compiler eventually. Okay, so we want to generate the cond first. So what do we want to make this? This should be a instruction branch cond. Yeah, LLVM might be a little bit far off. It might be a while, I fear, but it'll be good. It'll be good. The way you're working, you'll make it big? I sure hope so. I appreciate the sentiment. Okay, so what do we do with cond? What is cond again? Cond is a value. So then, cond. Yeah, because cond already exists. We've already evaluated cond up to this point, I think. So it takes cond, then we take. Oh, that means we can't reuse cond. Cond. Okay. So we have the condition, and then you can't. Okay. Let's see. So we want a unique putter, I think, right? Unique putter to instruction branch cond. This will be icond. Subway surfers on the side. That might make a funny April Fool's stream. I might do that eventually. Actually, let's. Okay. What do we do here? Cond instruction will be as else. Then it's. Oh, this is gonna be a mess. If there's a way to make this prettier, please let me know. Yeah, I guess you'll have to split screen Subway Surfers yourself for now, unfortunately. This will be cond T label, F label. Otherwise, it'll be the whole same thing. But so this is cont label. What's wrong here? Instruction branch. Oh, I need to move, huh? Oh. Oh, this is annoying. This is really annoying. Do I just not have a constructor for it? Is that what's wrong? Comp T label. Yeah, that should be fine. Oh wait, no, this is no. I see what's wrong. This is not a control flow graph. Okay, so we need these labels at the top. So then we have the cond, and then we need our first label. I guess we can cond T label equals okay, let's get rid of this mess first. Okay, so we want T label dot arrow get name dot get. That's what we want, I think, right? No, we need to make a copy of it because we don't do pointers yet. Yuck. So we want. Oh, this is so awful. This is terrible. Okay, how do I make an atom again? How did I write this? So we need to give it close monetization? Yeah, that's true. Not that money is like that much of a pressing concern for me right now, at least, so it's not really something that I'm like paying too much attention to. So we want T label dot get name dot get value. Yeah. What's wrong here? Arrow. Yeah. Arrow. Then we need F label. LV. I'm sure that's true. That's true. That's quite important, actually. Okay, so we need another ternary operator here. Has else. Then we do the same thing here for F label. Otherwise, then it's cont label. Right. Okay, that works. It looks a little bit ugly, but it's fine. I promise there's a reason for that. What command line are you using? I'm using Westerm with Fedora in WSL. And I use Bash because I don't see a reason to use any other shell. And yeah, you're right about Windows and NeoVim. I'm only on Windows because I low-key have a Valorant addiction that needs satiating at times. Okay, so we have the true label, we have the false label. So then we need to actually make the cond. What rank? I'm currently Diamond 2. I did my placements a bit back, but I've peaked like Ascendant 1. So we want make unique. And we need this again. Pond. And then we need pond T label, pond F label. Okay. So that's one instruction out of this whole pile, or I guess in this diff. So we have this top line done. So the true label, yeah, so let's start inserting things into the AST at least. So we want result dot push back cond I, or move cond I actually. Yeah, I've spent a little bit too long in Valorant, for better or for worse. Okay, so that's the easy part. Then we want to move the T label. And then the nice part here is we can actually, I believe here we can just recursively visit the body for both of these, I think. So we can, Vanguard's judging? Yeah, it very much is. Okay, so we can just accept the visitor. So then, this is gonna be great. So we can get this. I get T branch dot accept, and then we can just accept this. So that recursively generates the true branch code, I think. Yeah, that should just push back whatever it is. Let me just make sure that's how it works. Yeah, okay, perfect. So at this point we've gotten through the the first dot 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 here. So then we need to handle generating code for this branch at least. So if we have an else, so has else, then it's pretty simple again. We kind of just do the same here. But we change this to F branch. This is F label. What parts of C are implemented? We have like some basic arithmetic / like binary operators. I'm going off of most recent C++ version. I don't think the set of features I have really is expansive enough for that to matter though. So we have like basic binary operators. We have function calls, but no parameters yet. And we will have, I guess we'll have control flow pretty soon. So yeah. Data drive macOS, iTerm 2 is eShell, fair enough. Don't really use Windows for work, just games. Yeah, that's fair. Westterm is written to be pretty compatible with a lot of things, if I remember correctly. Realistically, terminal doesn't really matter too much though, in my opinion. Like, if it works, it works. I just like Westterm because I can configure it with Lua, and that makes me a little bit happy. Okay, so we have F label, so now we just need to continue. Yeah, I've heard good things about Ghosty. Aiden from above in the chat, he uses Ghosty if I remember correctly. I also used like the Windows native terminal for a while. Yeah. And this also supports like WSL, which is kind of crazy. Yeah. And it was like actually not bad. I used it for the longest time. I ended up switching because I want to be consistent, but yeah. My laptop is running Arch, so I figured it makes sense to, I guess, keep them similar. Yeah, the native Windows terminal actually does take like background images for some reason. It's like surprisingly customizable. So yeah, I used it for a year. I got through my trying to rice everything phase on Windows, and then I picked up Arch and I immediately regressed. But you know, that's how it is. Okay, so now we just need to push back the continue block. So this is const label. Yes, I daily drive Arch. I take my laptop to classes, and I try to avoid working in my room, even though my setup is low-key nicer here. Okay, so this is done. Yeah, WSL is... Honestly, I would say WSL is the greatest thing that happened to Windows, but it's more of a tragedy that we got to a point where we needed WSL. Windows' whole strategy of just making the world dependent on them for market share superiority really did not work out well for developers. So WSL is kind of just a band-aid fix, for better or for worse. Yeah, the only reason I do use Windows is just Valorant. So, so it goes. I considered dual booting at one point, but honestly it's just more work than it's worth for me right now. And this setup works sufficiently well, so it is what it is. Okay. I think we need to implement these visitors, I think. Although I guess they're... We could probably get away with not right now. Let's see if this builds. I hope this builds. That'd be great if it builded. Yeah. I have a separate test directory just for like running things easier. So AST prints out the if statements properly. Make HR. Well, this looks really ugly, which is kind of intentional, but something seems wrong here. Something seems very wrong here. I can't really tell what's wrong. Something tells me we're generating a lot of incorrect output. Let's look at just the basic if. Yeah, something... I can't tell what's wrong here. Oh, I know what's wrong. Mac Mini, MacBook Pro. Yeah, I think that's fair. Ah, that's interesting. Yeah, I don't know. I feel like how frequently I use my different systems kind of ebbs and flows. Or ebbs and wins, I guess. Like sometimes I'm just really feeling laptop with nice window manager and like usable keybinds. And other times I just feel like being brain dead with like a Windows machine that has like a GPU in it. So like everything, I think as long as like everything has its own purpose and nothing is like too duplicative in the value it provides, I think it's probably fine. Yeah. At one point I wanted a Mac, but low-key I've spent enough time on Arch that I couldn't really live with any other package manager. So I was like, fuck that shit. And I just got another Linux capable machine. Oh, what I want to change real quick was the toString. To do is not here. What's it here? Where'd it go? Oh wait, this is the wrong place. That's why. It should be here. There we go. Let's make the label real quick. Label should be pretty easy. What's your opinions on React? Only good ones. React should not exist. We should not have gotten to a point where we needed React. Alright, so we just call a toString on the label, and then we add a colon and call it a day. So we want label to equal, should be L, because I made it L. So I get name, toString, and then we pass in symbol table. Spaces, and then, oh, we're gonna need prefixes, I just realized. Thought we could escape the scopes, but I guess we never can. Actually, no, we don't need to. We don't need prefixes. This is great. Yeah, okay, perfect, actually. Arrow, okay. Let's build, let's try this again. The reason why it's vomiting out all of this is because we don't clear when we called the not implemented ones, so let's see what it does now. Okay. Well, so we still don't clear for some of this, but yeah, because we haven't done branch yet, at least. Oh wait, am I missing an instruction? I just realized. Or at least in the visitor here. Was it here? Yeah. Make label. Okay, here. So if we go back to the big diff, I forgot this branch continue, I think, which is generated here for sure. So we have the F label here, which corresponds to this line. We have the ... here, but we forgot the branch continue. So we want, I'm gonna make a branch continue. So we want to, uh-oh. So we're gonna steal this line. Let's put it down here. Cont label. So we do that, and then so we want auto should be cont, I guess, like continue label continue equals, continue is not a keyword, right? Right? Is it reserved? I think it's reserved, man. Continue I. So we make unique again. This takes instruction branch straight up. And then we just give it continue label. Oh, I need to move it into it. And then we can push this back. I need to move it back. Okay. Interested in cyber, graduated with a bachelor's and doing a master's. Ooh. I take 2 semesters. Focused too much on GPA and didn't get much experience. Yeah, I think that's fair. For what it's worth, I think cyber might be the easiest CS subfield to, I guess, get like personal experience on. There's like whether it's like bug bounty or like hack the box or just like other various like cybersecurity beginner resources. There's just a lot to work from, and it seems pretty well defined at least. So if you get like experience with that, and then like maybe like do a bug bounty or 2, I think you're pretty much set for life. Is this WSL? Yes, this is WSL Fedora. I'm on Windows because I have Valorant addiction. Okay, so I think this fixes the one thing that we missed. So now we can fix the toString, I think. This toString should be pretty easy. Let's just like, it's about as trivial as the label, I think. So we can just steal this real quick and see how much of this we can paste here. Get label, and we can do that. So we have space, and then we have goto, I guess. We'll just call goto, and then label plus semicolon. There we go. And then we can do this. And then T label, F label, T label, F label. And this will be a little bit more annoying. We'll just call this goto if for now. I don't know what I want to call it yet. Because goto, like conditional goto doesn't really exist in C. I don't have like an equivalent, so I do necessarily just have to make something up for this. Let's put the condition in parens. Just do this for now. Save this. What does a goto look like in C anyway? Oh, it's just straight. Okay, sure. Yeah, so we can do this, and then we want cond equals I get comp toString. Yeah, okay. So we want cond, then T label, and then we got space. We should make this just character, and then F label, and then we give it a semicolon. Oh, this is a function. There we go. So this build, let's see what this does. Let's see if this generates code that makes me happy. I hope it generates code that makes me happy. Okay, let's start reading. Okay, so if cond1, then we go to if t0. Otherwise, we go to if. So then we go down to if cont0. Yeah. Okay. This looks correct to me at a glance. Basic if else. This should be a little bit more complex. So we have the two conditions. There's one of them. There's a dead goto here, but that's fine. We have this. Is there a way we can get rid of that redundant goto? I guess I'll let the optimizer clean it up when I get around to implementing that. My camera's doing something, 1 second. There we go. Yeah, okay. Wait, what? Oh, I see. Yeah. That looks really silly. And then no braces should do the same thing. That and that. Da-da. These returns make it a little bit ugly, I guess. But I don't even know how I would generate this. I guess this is just a lone terminator, so maybe that would just get its own basic block. Yeah, I guess that would get its own basic block, but what do you do with that? I guess it'll just get eliminated with like dead code elimination. Because we can just like we could just check if each basic block has predecessors. And for every basic block that has no predecessors and is not the entry node, I think we can just nuke. And that solves a lot of problems, I think, with cleanup. Okay, chain is the interesting one here. So if cond1, then we go to that. Otherwise, we go to if cont3. Oh, this is really funny, actually. Yeah, that we will have a pass to clean that up as well. So that's not really that confusing, but looks like the nesting is done correctly at least. So if cond1, then go to that. And then if cond2, if this is the thing, then we go to this. Oh no, that's not what I want to do. So that should be this, and that's right there. If that, then we go to if there, return 0. And the rest of these, I'll go down here to return 1, it looks like. So that's correct. Yeah, this all looks roughly correct at least. It just looks like a little bit of a mess because there's so many labels, but I promise it's all coherent. Work on my third certificate, Security Operations Center Home Lab. Ooh, yeah, that should be pretty reasonable on a resume. Yeah, I think you should be pretty set for what it's worth. Cybersecurity is definitely a little bit out of my depth, so I can't really give too much advice, but I mean, if you keep trucking along, I'm sure good things will come your way. Okay. Graduate teaching assistant, I see. That makes sense. Yeah, that seems fun. I think all of that resonates pretty well, so you should be in a pretty reasonable spot. This syntax is really ugly. I want to clean this up, but I think this is kind of what we have to stick with. Maybe I actually just make these labels. Maybe I give these labels like empty lines after, or like before even. Yeah, I'm gonna give them a new line. Build. Let's try this though. Yeah, that's more readable. That's way more readable. Holy shit. Okay. I'm like not going insane anymore just looking at this. Okay, so we can push some stuff. ST to HIR. Implement ST to HIR for if statements. Oh, I need to format. Damn it. That's not the right file. Wait a second. There we go. Let's just add that again. Yeah. As much as I get annoyed whenever my my format hook fails, I guess it's important to have just so my code looks pretty, Because as we all know, that's the number one reason to write code. It's not to actually make things that work, it's to make pretty lines of text show up on the screen. Okay. So we have that, and then we can just do implement toString for new HIR constructs. Okay. So that's the start. The only thing we have left to worry about is now just going from HIR down to MIR, which honestly shouldn't be that hard. The only annoying thing here is previously we assumed that we only have one basic block, which was a very safe assumption to make because we didn't have control flow. Because like our code execution was just like completely linear, barring like function calls. But in terms of like the control flow graph, it was not really a graph. It was more just a control flow straight line, I suppose. So we could make the very safe assumption that everything would just live in one basic block. Unfortunately now, it's a little bit messier because we have to worry about multiple basic blocks in our CodeGen. With that being said, the lucky thing is if we look here, we pretty much just have basic blocks generated. Because each label is the start, we can think of as the start of the basic block, and then they either end with a terminator, or if they don't end with a terminator, we can assume that it just goes to the next label. Yeah, so like as an example, even just like these continuous continue labels. If we go to the 8th continue here, the next one will just be the 7th one, and the next one will just be the 6th one. We can kind of just like group these all into like one line, sort of. So the idea here is we can just iterate through the instructions as we currently do. If we hit a terminator, we make a new we close the basic block. If we hit a label and the previous basic block hasn't been closed, then we close the previous basic block, and then we just keep going, I guess. Yeah. And then this also should be pretty scalable to handle loops as well. Like for loops, while loops, and do while loops are all pretty much just like different arrangements of like this conditional go to, just the straight up go to, and then labels. It's just instead of always jumping forward in the labels, it can potentially jump back in the labels. So yeah, it should be a good time, but yeah, we'll see how this ends up turning out. Yeah, okay. This is gonna make a mess. Okay, so the nice thing here is we don't have to change the logic here, I think, because we're just keeping a vector of basic blocks. So it should just get all the basic blocks per function. And I guess I should back up real quick. In case you're not familiar with compiler theory, a basic block is just a straight line execution of instructions, so without any branch statements whatsoever. So if you go to the start of a basic block, you can pretty much guarantee in most circumstances that your code will just execute straight down until it gets to the bottom. And then the last instruction is a terminator, and that means that it either stops execution or it goes to a different basic block in some capacity. And that allows us to simplify the control flow graph for our program very significantly. Okay, so we just need to implement these visitors. Okay. So label is the most complex one, ironically, I think. Okay. Let's just double check how we implemented return real quick. Yeah, so we literally just make the basic block and then we clear the current values. Okay. We might need to keep a basic block mappings, I think. Do we do that? I hope we do that. We need to keep basic block mappings. Yeah, it's gonna be a little bit annoying to link them up, actually. Okay, let's give this a try at least. We can try something out. So the branch we can kind of just treat as this, roughly. So we can copy all this in, I think. That should be the simplest one. We can just nuke some of this real quick. We need label mappings. Okay. So you want u int 64 t, and then fuck. And this maps to, I guess, basic block, huh? Yeah, that actually solves a decent amount of our problems, I think. No, because then we have to worry about going to a basic block that we haven't created yet. Maybe we do one pass that, like... This really sucks. Give me a second to think about this. I need to think about how to implement this properly. This mapping thing. I think one of my professor's old slides, I think, has something here. Let's see. Probably in here, right? No, it'd be in here? Yeah, okay. Oh, there's also like other memory access stuff I want to implement eventually. So for each instruction, okay. So you go to master student. Well, this is like my first quarter. I'm still kind of like in between. It's like a really awkward limbo. Since I guess I'm starting the combined BSMS program here, so I'm like sort of a master's student, but it doesn't really feel like it, I guess, if that makes sense. Like, it feels like it's just an extended undergrad experience. I'll graduate with a master's by, I think, pretty much December 2026. Assuming I don't have, like, other, whatchamacallit, other, like, thesis-related extension stuff I need to worry about. Yeah. That's, like, the only thing that might mess with my graduation timeline a little. But even so, that's, like, 1 or 2 quarters more tops, surely. That's still a good time, I would say. This control photograph stuff is like really messing me up. So this is BB mappings, I guess. Yeah, the problem here is we'll have instances where like the basic block that's associated with the label just doesn't exist yet. And that creates like a bit of a mess I need to clean up. I don't really know what to do about that is the other problem. So it's like, I guess like yes in a sense, but it's like, I'm technically both right now, I guess. That's where the kind of limbo-y feeling comes from, I guess. Nah, you're good. I'm kind of just like, I do need to just like cook in both in terms of like masters and in terms of like this algorithm. I have no idea what the best way to do this is. Maybe I throw ChatGPT at the problem and see what it says, just out of curiosity. Yeah, this makes very little sense to me the more I think about it. I'd probably have to do 2 passes. That's really annoying. Can I collapse the pointer in some way? Maybe I'll just feed it null pointer and then I can like update the instructions as we go, but yeah, I'm gonna need to like add update instructions for these branches anyway when I implement like control flow graph simplification. So that might actually make the most sense, I think. Okay, yeah, let's give that a shot. I think that'll make sense. I think that will reduce the headache I have at least. So we got a quick little tangent. Let's go to middle end. Yeah. So the returns we don't really need to change anything about because we don't have to worry about successors. So we want, where do I have the setters? After all of the getters. Okay, that's my convention that I will do. So we want set t successor. And this will be basic block quitter. Yeah. And then we can like keep a kajillion maps and it'll solve itself, surely. Yeah, here, and then we can set false successor. And then we need to do the same for the just unconditional branch. But this is a lot easier. Okay, now we have to implement this. Let's actually just keep that up there. 21. Terminator. I can't type. It's always a good day when I can't type. What's wrong here? There we go. Okay. Actually, we can just copy these two as well. These go above accept. So this is Terminator con branch. So then this. And then we can change this to T successor and this to T successor. Okay. Yeah, this was something that I needed to do anyway, just because for a certain pass that I'll implement later, which is like simplify control flow graph, what that will do is it'll end up merging these sorts of straight line connections. So I guess part of that simplification will just have to be like just like sticking the instructions from one basic block onto the other one, just joining them into one big block, and then we have to like change the successor order of them. So yeah, this was something that we needed for that anyway, so that's like whatever. Let's push these real quick. Let's add, whoops. Add setters for Terminators. Okay. So with that, I think we can finally go back to this abomination of a program, and we can start figuring out how to clean it up. Yeah, okay. So then we can just set them to null pointer for now, if it doesn't exist. Right? Yeah, we could just set them all to null pointer, to be honest. I think that would be easiest. Yeah. So let's do that, and then we can do one big pass over all the basic blocks once we have them all. Yeah. Maybe we keep a map of all of these and then we can just iterate across those, and that would be easier. Yeah. We can also make a helper for that. So we can void connect basic blocks. I don't like this basic block mappings thing, but there's a better way to do this. Let me think. I guess we could just like, we could just give it vectors. That might be a little ugly, but we could just give it vectors. And it's either one element vector or it's a two element vector. And I hate that I'm saying this, but this might actually just be the best way to do it. This should be Terminator mappings, I think. Right, oh wait, we need both actually. So basic block mapping, basic block mappings. Then we need we give it instructions and then a vector of uint64t. What's wrong here? Oh, we don't have, you can't hash that. You can't hash vectors. God damn it. Come on. Add a break and continue? Nice. Yeah, I guess. I guess those would also be nice for me to add now that I think about it. Maybe I should add those with my loop slush. Yeah. So what I've done today so far is just I've added labels and basic branch stuff. You can overload hash for unhashable types. Interesting. Yeah, I guess I could do that. But what if I just use a map? Just a normal map. What's wrong? Oh yeah, duplicate member. Okay. So this is. Yeah, I can just do this. Yeah, I mean that's fair, but also I feel like surely that's already like well defined for vector at least. Maybe there's a better way to do this. I mean, I guess I'm just iterating through these. So it could just be a vector of pair of instruction and, oh god. Okay, maybe we don't do it that way actually. I might actually do that though, the more I think about it. This is gonna be awful. Yeah, we're gonna do a vector of pairs. Does it let me do this? This should be Terminator. Maybe I should just make these. Yeah. Yeah, that's probably a good way to go about it. This isn't even a question of is it fast or not. This is just me looking at this type and just thinking this is one of the ugliest things I've looked at in a hot second. But I mean, we can like, yeah, it'll make the underlying code like pretty, right? Like we can do like structured bindings, like, or whatever they call it in C++, like, you know. Okay. So then, how do we preserve the label to the mapping? I'll figure out a way to make it work. For now, I'm just gonna get these done at least. I think it should be pretty straightforward-ish. Yeah. So branch, it just has. It's just a terminator, but we're kind of just sticking a null pointer in it for now. So auto branch equals. This is gonna be the most boring make unique in human history. So this is MIR terminator a branch. And then we just give it a null pointer. Okay. And then we go up here, we copy that. Then this should be branch. Yeah, okay. If there, how do we keep track of a label corresponding to this though? That's the only other question that's in my mind at least. Yeah, we'll do this for now. And then we can do the same thing down here, I guess. Oh, but this has a cond actually, so this is like a little bit interesting. Cond should already exist, so we want auto cond equals solve atom. And this is I. We wanna. Is this I or is this T? Is that what we called it? Yeah, it's an I. Okay. So we get comp. Oh, what's wrong here? Do I need to move? Oh, get. There we go. Let's. Oh, sure. Okay. So we have the cond. So then this is cond branch. Now we can give it cond and then null pointer and then another null pointer. Yeah, that's pretty funny. Okay. So then we can just add this and then we can clear again. We need to add this to like a mapping somewhere though. We can easily add it to instructions to basic blocks. I don't really know how I'm gonna generate basic block mappings, at least for now. Okay. I guess we could just keep a vector of both. Yeah, because each label and terminator, I guess, are one continuous unit, I suppose. The other thing is we need to like figure out auto label generation in some degree. Okay, well, yeah, this is already like a complete mess, but I guess it'll have to do. Yeah, I think that's kind of the best way to do it. Yeah, so let's just make a vector of uint64t, which will just be corresponding to the label, I guess. Yeah, we can just do that. I think that'll make it a little less ugly. And then we can have this like correspond to basic blocks as well. Yeah, not very elegant, but what can you do? Okay. So, what's wrong here? What am I missing in HR to MIR? Instruction is an abstract class. The hell did I change? HR to MIR. Oh. Instruction player. There we go. All better. All fixed. Okay. Cool. Cool. Okay, so at the terminators, we want to add to instruction to BBs. Is there any other complex logic we need to account for at the labels? We need to account for, I guess a label indicates the start of a basic block. So we could just create a new, I guess if the previous basic block isn't closed, it's just a straight line connection. So we could just make that as well. Yeah. And there will be a lot of duplicative code, but we'll make it work. We'll make it work. Yeah, so this is all fine and dandy. We in place back. We need to update instruction to BBs. So let's add branch.get, and then let's give it, what do we give it? I get t label dot get, and then I get f label dot get. What's wrong here? Oh. Wait, no, not dot get. Get value, I think. Right? There we go. Okay, we fixed it. Perfect. Ugly, but we fixed it. Now we do the same thing here. But we just have a one element thing. Let's just get label. Okay, nice. Okay, those are the only ones that we care about. And then now we need to actually figure out labels. Okay. So we want to close the basic block first. Yeah. So with cur instructions is not empty. Then we want to add a straight line. Yeah, so we do that, and then we can simply add this to the mapping, I guess, which will be neat and dandy. So we can push back L dot get name dot get value. There we go. There's probably a better way to do this, surely. I guess not. Yeah, okay, because each label should correspond to a close somewhere, or a closed basic block somewhere. Except for the first one. So we might actually just need to add a dummy value to labels. Yeah, that might be useful anyway, just for like an entry block. Yeah, because I think that's how LLVM handles allocates, right? Let me just check this in Godbolt. Ignore what I was doing here. I was trying to make a while loop with a for loop, but so we want I equals 0 and j, or s should be j. If I greater than 5, then j plus equals 1, else j plus equals 1000, return j, sample program, O0. Yeah, okay. Salt entry. What happens if I have like a stack out? Or what if I make a variable in here? Let's just do that. I don't care about formatting. This is going to be ugly. Yeah, the allocate gets hoisted, it looks like. Or at least the allocate is hoisted, it looks like. Yeah, okay, well. LLVM mem to reg, which allocates. Okay. Oh, I see. Okay. Yeah, that makes sense then. Yeah, so I guess it gets hoisted, which is fine. We can like clean that up as we go. We might need to keep like an entry block somewhere though, but that's fine. Yeah, I would need to hoist all of them, I think, into an entry. Yeah, we can just make an entry block even. But that'd be like annoying. Okay, cool. So let's. Okay, let's handle the label problem first. I think this is easier to resolve. So just adding this connection here. Yeah, so we can just copy from here, Loki. Yeah, we can kind of just steal everything in here, which is really funny. So we make that. We want to push back branch, and then we want I'll get value or get name, and then we can get value. So that's a straight line connection, and then we make the basic block a thing. And then maybe we need to keep track of like previous instructions somehow. Actually, maybe we just handle that up here in this loop. And then we can like keep track of previous I as well. Yeah. Okay, we want to keep bool new basic block. I guess we can do that. That's true by default. And then yeah, we can do that. Yeah, we can do that, and then if it's a new basic block, actually, maybe we throw it in here even. I hate the amount of mess I'm making. Yeah, this one we need to initialize actually in the constructor, but that's quite straightforward, I think. Oh, come on. So we want, oh, we have it defaulted, but we can't default it, I think. What do we do with lowered functions? Oh, I see what we do with it. Yeah, okay. Yeah, okay. Do that. And then we can just set new basic block to true. And that solves every problem, I guess. Okay. We could do something really hacky here and just like make a label for the thing, but like, why? This is terrible. This is truly terrible. I feel like I've cooked too hard. So what is the logic we want? So if we have a terminator and then a label, then there's no problem in that order. If there's a terminator and then a label, or if there's a terminator and then another non-label, then we want to insert a label. Yeah. When I just create some arbitrary label, I think. Yeah, then we create a label. If there is no terminator but just a label, we do a straight line connection. So that one's like pretty easy. I think we got that at least. Actually, we don't need this new basic block shit. We do need labels though. Let's get rid of that again. And we can't do like an empty check is the thing as well. No, we do need this new basic block thing, I think. I think we do need that, unfortunately. Okay. So then that means we can put the logic in here, actually. So if it's not a new basic block, then we need to close the existing one. We do that, and then new basic block equals false. Real quick, after all the terminators, we can set that. We do it in branch, and then we do it in this as well. But we have no way of checking the other condition. Doing it this way, so we have 3 cases that we care about here at least. So terminator, then label okay, we have instruction, then label, create straight line. The problem is we don't have anything for terminator, then instruction. We could just do like a make label if missing, I think. And I think that would actually clean it up. Yeah, okay. So we want visitor.make label if missing. Do that, and then we want visitor.connect basic blocks. Make label if missing. Okay, neat. Neato. I guess this would make it like unreachable code, huh? Which is interesting. But we can clean that up with dead code elimination, I guess. Yeah, because that, yeah, okay. I have ambitions. Yeah, so this is fine. We need to implement that somewhere. Put this here, and then let's just to do these up. Okay. Okay. So we need to handle this case, which again we can just copy this stuff just straight in there, I think. That, and then we want L get name dot get value, or arrow get value, and then push that back, and we can clean that up. We don't need to set that flag, that's a little redundant. Okay, that roughly makes sense to me. So now we just need to implement make label if missing and then connect basic blocks, which should not be that hard actually. So if new basic block this should also take the instruction actually, because we need to check if it's a label. If the instruction is a label type, then we can just continue, but if not, then that's the problem. Yeah, so let's give it I, and this needs, so we need mir instruction, not mir, hr. Instruction putter, I guess. So if it's not a new basic block, or I is a label, then we can return. Alright, it's just a label. Whoops, that's what it's called. Label putter. Yeah, okay. So this we only run this if it's a new basic block and I is not a label. Yeah, okay. So we've done this correctly. Yeah. So if it's a new basic block and it is not a label. So yeah, we've De Morgan's lawed it correctly. Okay, so now we just make a label. Okay. Let's say a default value here. Int max, I guess? Surely we don't need int max. Right? Can we assume that a label is not a zero? Or not a zero identifier because... Yeah, we literally have a function name that comes before it. It can't be a zero. Yeah. Yeah, we can just give it a zero, actually. Yeah, so we do that, and then... I should probably add a comment there. Okay. So we can do that, and then what's wrong here? I.get. Yeah. What do we do for label again? We just push back the value, I guess. Yeah, that actually makes complete sense now that I think about it. We don't need to like make an instruction or anything. Okay. Alright, cool. Cool. So now all we need to worry about is this abomination of a function. Okay. So we want to generate a mapping first, and then we can just iterate through the basic blocks, and then like just mess with the terminator. Yeah. We don't need to worry about giant dynamic hash trees because there's only like three possible terminators, and one of them's a return, so we don't really care about most of them. Yeah, so we can just so auto or int I equals 0, I is less than labels dot size I equals plus, and then we want to map from uint64t to basic block putter. So we want label to eb. And then if this is 0, then we can continue. Otherwise, then label to bb at I, or yes, labels at I will now be basic blocks at I, one-to-one mapping. There we go. Yeah, okay. So that makes the mapping, and then we can iterate through instruction to BBs. So we have instruction and IDs, and in that field. Okay, that seems valid. So then I C branch, or I guess like branch equals, we can dynamic cast I to terminator branch. A terminator branch putter, rather. So if it's a branch, then we set to IDs 0, I guess. Do we push these back, by the way? Yeah, we do. So we get the branch putter, and then so then I dot, I guess branch dot set successor. This just gets IDs at 0, actually. Or wait, no. Label to BB at ID 0. Let me just clean this up a little bit. Okay. So now we can do the same thing again, but for conv branch. What's good, Yatar? Welcome to the stream. What I'm doing right now is I'm trying to get branching control flow working in my big slush pile of a compiler. So, yeah. I'm doing well, thanks for asking. Still a whole lot of complexity to think about. Let's see, that, and then f successor ID equals ID is 1. So this should be conv branch. Do that, and then we can change this to f successor. Yeah, like that. Perfect. And then I think we should be good to go. I'm really scared. Something's gonna break. Let's make sure I didn't like break anything incredibly drastic or anything though. Okay, test. Okay, everything runs at least it looks like. So then make, oh right, because, okay. Yeah, fair enough. Yeah, that's something I forgot I need to worry about. Just got out of a TR debugging session, I'm dead, man. Happens. Yeah, I fear I'm about to hit a 2-hour debugging session as well. I know what's causing this to crash, but I can't do anything about it right now because I don't have a way to turn this into an I1. Okay, we're gonna need to add more types to. We're gonna need to add more types to the whatchamacallit, the HIR. So let's add everything. Initial basic block support for initial branching control flow for HR to MIR and to format. Which file do we need to format? HR to MIR CPP? There we go. Okay. Yeah, hopefully this doesn't take too long. It's just I need to like literally extend this a little bit more, which is annoying. Okay. So what do we need to extend here? We need to add I guess we need to add like a compare operator, which is really funny. But this is really annoying. Okay. Do we have any real binary operators in the middle end at least? This is where we'd have to start. Wait. Oh, I see. Okay. Real quick, let's search up to-do real quick. Let's make sure I covered all of the reasonable ones. Yeah, okay. All of the ones that are left are fair to leave. Oh boy. Okay, how do we want to do this? So it is a binary op, but yeah. What happens in Godbolt? Just as a reference, if I were to do something. So int j equals I greater than 5. Is this just one instruction? Oh, so it's literally a compare and then 0 extend. Okay. Yeah, I guess assignment gets its own little bracket, which makes complete sense, but that's just a shortfall of the way I have things implemented right now, which I guess will be the next task after I get all this working. Okay. I think this is fine. We can just like add a validator of sorts. Okay. Let me add that to the big to-do pile actually. I have to coordinate things for dinner, so I'm checking right now. Okay. Sure. So then I want to add to this list. Maybe just like a simple verifier might be interesting. Okay. So this is fine. And then we need to add an operator. So we want to check greater than, I guess. Maybe I should do like signed greater than real quick. So we'd add it in here. We'll just do signed greater than for now. Oh wait, no, this is a completely different operator, I just realized. This is the int compare. Or it's just icomp. Right? Is that what it is? Yeah, int compare and float compare are different. So we have comp operators. Yeah, so we can just do this. Okay, so we want enum class comp op. So we want sign greater than, I guess, for now. Okay. Sign constant unordered map. This is because eventually I want to write a parser for the middle end optimizer, or the middle end IR. So comp op. There we go. And then we need another toString. You can just copy this. Return. Let me just check if I don't need to go right now. How much time do I have? Oh, I got like an hour and a half. Okay, we're fine. I can keep tapping. Okay. Actually, maybe we could do all of this in one big commit. So we can do that here. And I guess we just add it in the middle end, or oh wait, no, we just don't add it in the parser. So we can add it in here, I guess. And we do the same thing. Aww. Aww. Okay, well, we're gonna make a mess, but that's okay. So this should be greater than, I guess. Should actually go under. We can just do all of these right now even. But then we also need to add like signed as well, I think. Yeah, let's just extend to do all of them for now. Actually, I lied. Let's not do that. That will add a lot of headache for me in the future. So this will be greater than. What exactly are you doing? Right now I'm trying to extend my compiler. So I'm working on a compiler from C to x86, and right now I'm trying to implement like if statements. And the problem is I don't have Boolean values, so I need to make those to make this work at least. Because we can't really be supporting Boolean comparisons without Boolean values, I guess. So it's a little bit stupid, but so it goes. Okay, so compare greater than. Okay, we need to copy this as well. And then we can copy this, but this also needs a little bit more interesting stuff, I think. Yeah, because we also need to give it a sign, I think. What's your compiler capable of doing right now? Pretty much just like straight line instructions. So we have these 4 operators supported, just between like 2 numbers, and then we have function calls, and that's pretty much it for right now. A lot of this stuff has been just like setting up the groundwork, but we're slowly getting to move faster. And I guess that's part of this whole experience. All right, let's implement these. This goes in HR. No, it wasn't utils. We want greater than. We want return greater than. Huge. And then this function will be a little bit different. Should also be comp op. Okay, so we want, if it's signed, then we want a certain path, and then else we want another path. Oh wait, I did this wrong. I need more braces. Lol. Do this for now. Let's just throw this in here. So if it's signed, so we want return MIR. Comp up. Oh, we want SGT. And then we can just deal with that. We can throw that here. We can throw that there. We can just steal this again. Actually, yeah. We'll just throw another unreachable in here for now and call it a day. We'll extend it in the future, but for now I think this is more than sufficient. The other thing we need to implement is the actual, I guess, like, operator. Yeah, we want this. We can worry about zero extend in the future, or sign extend in the future, I guess. Yeah, this, yeah. This is what we need to do. Yeah. So to compare. Start CMP operators. Oh boy. Okay. All right. Okay. Cool. All right. Cool. Just so I can like test actually. Low-key, I want to eat soon, so next time I think that's what we implement. But for right now, at least, I think we can just take. There's a check in the constructor for the compare branch, and that was in here, I think. Somewhere down here, yeah. Yeah, so we can just comment this out for now. And then we can just try making and running. And then in the future we can handle that properly, at least. What's your stream schedule? Currently I plan on doing, or at least this week was a little bit funky because it was my first week back to classes. Historically, what I've done is just like every day, 7 p.m. Central, or just whenever the LeetCode Daily resets in whatever time zone you're at. But I've been kind of messing around with it. I'll try to stick to that sort of schedule because I want to do more LeetCode problems. But I guess the best place to find out what it ends up being will just have to be my Discord. I'll make like an announcement at some point. I also want to like consolidate this upcoming week's stream schedule as well. So I need to think about that a little bit, but I'll post there. Oh boy. Out of range. Okay. Okay, let's start debugging. For cond. Into format. Okay, sure. can just do that, I guess. That. Okay. Out of range. I don't know. Why is that happening? Must be happening in the basic block linking, if I had to guess. So that'd be in here. Connect basic blocks. Unordered map. Yeah, so it'd be in here. Let's do a little bit of print debugging. Okay. So we want instruction to BBs. Right, no, we want to print somewhere else actually. The top. This should be basic blocks. Let's try that again. Oh, we don't even get to that point. Interesting. It looks like. Okay, we don't even get there. Surely we get there. Okay. Make HR. So it's like bricking somewhere here, I think. So how many are there? 1, 2, 3, 4, 5, 6. So the sixth one. 1, 2, 3, 4, 5, 6. Okay. So it's breaking at the return. Why is this breaking? Out of range. Why is there not a range? So we make label if missing. Maybe I print in there? Maybe that's what's wrong? More print debugging. Everyone loves print debugging. Okay, so we didn't even get there. Guess we shouldn't get there. Gaudy here. Let's try that again. Okay. So it is just straight up in the visitor. Maybe if I just put a print in the return real quick. Real. Print debugging, everyone's favorite. Okay, so it is in there. That's a fact. These shouldn't have problems, at least. Unordered map.at. Yeah, we're still going, still debugging. We're doing a little bit of print debugging now. Yeah, I could do GDB, but probably should learn at some point. I feel like it's just low-key gonna make a mess if I try right now though. Gotta start OS bet, let me know how it goes. Wait, what? Okay, so it's up here. We're just gonna flip those. Oh yeah, I forgot asserts exist. Even better. Okay, so it is in this, which I guess makes complete sense. What's going on here? What is this example? Oh, you fucking know what? I might have given an invalid program. That might have been what happened. No, this is a valid program. No. What the hell are you? Some of these definitely have to be invalid though. Let's just make this simpler. Turn 0. I feel like there's an invalid program somewhere in here that I forgot. Oh, wait a second. Am I tripping? Okay, no, I'm not. Let's just do con equals con plus 1. Just do that. 100. 100. Okay. This program's a little bit stupid looking, but it's valid, I think. This is fine. Let's get rid of that. Oh, Jesus Christ. Alright, these should all be valid programs regardless. So I guess that I was kind of tripping, but... Wait, but now it's breaking at a different place. Hey Janine, how's it going? Accept, and then done. Okay, the AST still exists. That's a good sign. So 1, 2, 3, 4, 5. Fifth instruction. 1, 2. Wait, what? Wait, make HR. Oh, that's the correct one. Okay. It's 1, 2, 3, 4, and then 5. What the hell? Okay, so con2 doesn't exist. Why doesn't con2 exist? Did I make con2 a thing? Oh wait, this is creating a mess. That's not a bug that I was ready for. Okay. Okay, let's see. Where did I fuck this up? I forgot that this is a bug I can run into. Do I have a movie to attend? I got like an hour. Yeah, I got plenty of time. So, okay. I think I know where this issue is coming from. Okay, I lied. I don't know where it's coming from. Okay, it's probably here. Resolve view scope. That should be fine. Should exist. Oh, wait, no. Wait. Uh-oh. Okay. Let's go here. Actually, no. I'm tripping. I can just split this. Again. So what's happening here? Con2 doesn't exist. Where is Con2 coming from? Where the fuck is Con2 coming from? Why is this breaking in use scope? It should be in here, at least. This shouldn't be making a new one. What? Maybe the way create scoped identifier is fucking this up? No, it definitely finds it in the previous scope here. So that shouldn't be a problem. Okay. Oh god, the AST is ugly too. Oh, so it's... Wait, what? Is the problem in the AST at all? No, it's not. That's fine. How haven't I tested this rigorously? Yeah, and then this breaks here, because Con2 doesn't exist. That's really strange. Why is this broken? Maybe even looking in, yeah, this is the one compared to this. Should be the same. Wait, what? Wait, this actually makes like negative sense. I think because I literally have a test for this, I think, right? Scope, yeah. The fuck? No, this makes no sense. Yeah, so it's definitely this, and then we set the scope correctly, I'm fairly sure. Maybe it's a bug in create scope identifier? It has to be this at least. The symbol exists. What's wrong here? Bruh. IO stream. Are you shitting me? What? How the fuck? I've never seen this ever happen before. Oh, did I forget to write? I forgot to write. Okay, all good. Make AST. This should make a mess as well. No, make HR. This should make a mess. Okay. Make HR. Let's do that. Let's look at this. Okay. Maybe if I just simplify this case again? What is happening? Oh, I see what's happening. Reassign.c. Okay, cool. Can't believe I didn't test for this or didn't think about this. So then we want cond equals cond plus 1. We can do that. Reassign.c. Okay, perfect. Yeah, okay. So now we know where the bug is living. Okay. So we add cond1. We add cond1. We add cond1. Why are we adding cond2? This tells me nothing, at least, which is really funny. So, okay, so that means we're getting the wrong scope. That makes sense to me, roughly. Except it doesn't make sense, because how are we getting the wrong scope? Like what? Huh? Okay, what happens if I stick more of these in the same scope? Okay, so it just vomits out more cond2s. Why are we vomiting out more cond2s? What the helly? What the fuck? This... Oh my god, wait, this... I know what's going on now. Oh my god. Oh, okay. It's not back. We should not insert at back. When we insert at back, we always insert it to the literal back. That is not what we want. We want to insert it in scope. Okay, this makes complete sense now. And unscoped identifier, I think we never need to worry about that. Okay, so now if we build, we should be in the clear. Yeah, that fixes it. Yeah, okay. That's crazy. Okay, that is a failure on my end for not having tested for that case. I'm a little bit, in hindsight, it's like such an obvious case that I need to test for, but so it goes. Okay. So now let's get rid of that. Let's switch this back to if.c. Okay, so something else is breaking now. We're missing a label somewhere. What did I fix? AST. I should get rid of this. I should add a quick test real quick, just to clean this up. Make sure this is safe, make sure this is stable, make sure this is human. Okay. Actually, I lied. I'm gonna save that test for next time. Let me make a note. Where'd my sticky? There's my sticky notes. I'll do this tonight, actually, just off the stream. Holy hell. Fix error in AST to HR with in descoping with reassignment. Okay, perfect. Okay. So what's going wrong now? There is way too much output to read. We have a mismatch somewhere in scope numbers though. So we can safely say it's here. I don't think these are wrong ever anymore. Make. Okay. 3, 3, 4, 4, and then 5, 4. Okay. So this should have, this makes 1 here, 2, and then 3. That's fine. This makes 1, 2, wait, what? Oh yeah, 1, 2, 3, 4. This one has something wrong with it. 1, 2, 3. This should have 4, but we're missing one somewhere. Oh, I think I know. New label, new basic plus. Yeah, this doesn't handle back-to-back labels correctly, I think. No, it should. Wait, what? It's 3, 3, 4, 4, and then 5, 4. So where does the okay. 1. Wait, where am I? 1, 2, 3. Okay, so it should be in here. 1, 2, 3, 4, 5. Oh, is this not a valid program? Wait. No, this is a valid program. It's a very interesting edge case, though. No brace if else. Yeah, so there should be one up here, one created here. There should be one created between these two. And 4, and then 5. Yeah. Does the return set the thing? Return should set new basic block to true. It does. Wait, what? These are the only 3 places. So then... Oh, what's good, Drip? Welcome to the stream. I'm trying to debug why my code generation is not working right now. There's so much background, I don't even know where to begin to explain it, so yeah, unfortunate. Do that. False. Okay, those should be the only places, yeah. Okay, that should be good, then... Oh, I should comment. It just occurred to me. It's 41 straight days. There was one gap day just because I was like flying back to school, but beyond that, it's just been straight, yeah. Oh, wait a second. There's no match at the end. Yeah, you can check the timestamps, or you can check all the days that I've released a video. It should line up at least 1-to-1, barring like some miscellaneous processing stuff. So what's generated here? Yeah, it's this fucker down here. We could just handle the edge case, and that would clean it up a little bit, but also like, Why does this happen? Or I guess how can we fix this? I guess we can just check that if there's an else branch and if there's an else branch and I'm trying to think what the logic for not generating this would be. Yeah, if both the if or the true and the false branches, if both of them generate a complete basic block, I guess. Yeah. I think I know how to clean this up. It'll just be a little bit of ugly logic. Let's get rid of all these. Okay. Yeah, so we just need to do a little bit of cleanup, I think, roughly. Should be in... Oh, wait, no, this doesn't make sense, because we need to generate further up, actually. We need to generate it here, I think, in the if handling. Where does that live? I think it's here, okay. Okay, I'm actually kind of lost now that I look at this. The only way this could happen is if every branch inside of it, I guess, doesn't return anything. I guess we can just make it return 0, and then dead code elimination will clean it up, right? So, is there an instance where that wouldn't work? Greetings from Maxuro, welcome to the stream. Okay. I mean, the lazy way to do this would just be to just skip whatever's left, because that's unterminated. But I feel like, when does that even happen? Right, because like if condition then else condition, or else then we can just life is good. If this is like return in here, and if this is return, then nothing comes after. But then if I have like an if in here as well, return this is the case that we can't account for. This would just be an invalid program, I think. What happens if I throw this into like Godbolt? Or some equivalent of this into Godbolt? It's less than. That, then else, then return 0. What happens here? If end, what is that? It just goes here. Oh, wait, what? Wait, what? What is in 2? Is load. Okay, so I guess it's just undefined, which makes complete sense, but so how does this handle like just return 1 in here? Maybe we just hoist like that. Or we just like make a separate return block. What to do? Yeah, because in this instance, this is like fine, but I mean, I guess we could just cut it off, because yeah. That doesn't sit right with me though. Okay, we're just gonna stick a extra return on the end, I think. Yeah. Okay. Are we deciding the behavior or is it a bug? It is a bug, but I'm trying to my idea is that like, okay, I guess let me alt tab back in. Okay, so we have this sort of slush of an IR. And then let me just pull up the source as well. Yeah, this function. So it's just like a very naive if-else generator. Yeah. So that's where the source of the problem is. But I'm trying to reason if like I guess it's because like if all of these have a return path already, and if cont0 is unreachable, then is there an instance where it's bad for me to just like tack a return 0 on? And the answer I'm thinking of is like no. What is the default return anyway? See default return value. If it's undefined, I can just stick a 0 on, honestly. Yeah, okay, well. Okay, fuck it. I'm sticking a 0 on. If it's undefined, no one cares, right? So surely this is permissible. Yeah. Yeah, I guess. I don't know. I don't have like the analyses to, I guess, determine if it's reachable or not. At least at this level. So. It's not undefined. Okay, well, maybe I'll change the way I generate return blocks, just to like, or I guess the way I figure out return is just like a literal return block. That might be easier. What happens if I do that? Nothing happens. Fair enough. Yeah, okay. So then we can just... What is a clean way to do this? Yeah, okay. I think that might actually make the most sense. Just a generator return block? Yeah. That shouldn't be that hard of a change though. I think I can make this work. So what happens if I just have nothing in here? Yeah, okay. Presumably this just gets a straight line connection. Okay, so then, yeah, I think that might actually make a lot of sense. Alright, so we're changing the implementation a little. Oh, that's all of my print logs, okay. So yeah, let's change that in middle end. Let's see how fast I can do this. How much time do I have? I don't think I have a lot of time left. Calendar. Oh, I have to be there in 30 minutes. Okay. Okay, what do I do? What do I do? Okay, let me check if I have mentions. Alright. I'm gonna probably implement this just on my own overnight, as well as the regression test. Re-implement return with a default allow or default or a return block. Just out of curiosity, one more thing I want to check here. Void. What does this do? Okay, I guess it just sticks a void into the return value. Yeah. Okay. Well. Yeah. Anyway, I'm gonna head out now. I really gotta start getting ready to go. Thank you all for showing up here. Even just like dealing with my wacky stream schedule this week. Next week, I think I'm gonna try and keep it consistent to just when the LeetCode Daily resets every day. Make sure you like the stream and sub to my channel. It really helps get my content out to more people, and it means a lot to me. We're rapidly approaching 1,000 subs, so let's get to that point, hopefully. While you're down there, make sure you join the Discord if you haven't. That's the best place to get notified when I go live, and yeah, get notified when I go live, and also chat with me outside stream hours and get the most recent stream announcements. And yeah. Make sure you connect with me on LinkedIn and add me on GitHub, so you can stay up to date with what I'm doing. And yeah, that's about it. Take care, y'all. Stay hydrated. Take it easy, and have a wonderful rest of your day.